This is the homework video for the review packet 4.7 to 4.9. So in 4.7, we are looking at solving equations for variables when we're given more than one variable, and we're not going to end up with just a single number for our answer. We're going to have an expression on the other side. So for number 1, we're going to solve this equation for y, which means get y by itself, which again, it's not going to say y equals, say, 10. It's going to say y equals and then have a full expression over there because this x isn't going anywhere. We're not plugging in for x. So we can't fully simplify this down to a single number. So we're still, though, going to treat this equation similarly to if x was a number. We're trying to get y by itself, and we're going to work on both sides of the equation. We want to isolate this, so we're going to save whatever's attached to y for last. We're going to add 3 to both sides. That's our dividing line right there. And that's going to leave me 2y. But x and 3 cannot be combined. They have to stay separate as x plus 3. Now to get rid of this, this is multiplication. So as always, we're going to divide. This whole side gets divided by 2. You could leave it like this. This goes away. So y equals x plus 3 over 2. Perfectly acceptable. But we do talk about how we break it up into 2 pieces, and you put both of these over 2 separately. And that's what you're going to see on the answer key. But the only reason we normally do that is because sometimes this simplifies into just like a nice whole number. Since it doesn't here, there's really no point in breaking it up like that. But we do need to know that both of these are equivalent. They're both the same. All right, number 2, get y by itself. Start with this. Now, when we see a number attached to a variable, a coefficient attached to a variable, we're so used to dividing to get rid of it that you might fall into that trap. But that would leave the x behind. We want all of it to go away. We're trying to get y by itself. We're solving this whole thing for y. So to get all of this out of here, I have to minus the whole thing, minus 5x. And so I got to do it on both sides. There's my dividing line. It's gone. So now it's 4y equals 20 minus 5x is what you're going to have on that side. Okay, you can't actually subtract and simplify that down to anything less. It stays separate. Those are not like terms. Divide by 4. All the way across. Now this is one where you do want to split it up because 20 divided by 4 is a nice number. So this goes away. You could leave this as 20 minus 5x over 4. The answer key shows you that. But when you split this into separate pieces, 20 over 4 reduces to 20 divided by 4 is 5. Now the 5x over 4, nothing happens there. So it's either you can put the x up top or you can put the x next to it. It doesn't matter. It says the same thing. These are equal to each other, though. I like this one better. It's more simplified. But again, just like here, they're equivalent. Okay, number 3, we want to get r by itself. This side now, all of it is being multiplied. So 2 times pi times r. Now, pi is a number. These are 3 numbers being multiplied together. R represents some number. So since this is all multiplication, I can divide to get rid of it. So I'm going to divide by 2 pi. You could do it one at a time if you wanted to, but it's easier just to get rid of it all of it at once. It's all being multiplied, so it all can be divided away. R equals c over 2 pi. Can't do anything more with that. Number 4, solving for x. So first thing I'm going to do is clear out this other term. And take a look here. 3x is still here. These are both y's. I can put these together. So a negative 7 minus 14, that's a negative 21y. Those don't stay separate. Those go together. And now to get rid of this, I just divide by 3. And negative 21 divided by 3 is negative 7. So x equals negative 7y. Number 5, e equals mc squared. We want to solve for m. So we want c squared to go away. Well, c is being multiplied by m. C squared is being multiplied by m, so I can divide by c squared to get rid of it. M is now by itself. M equals all of this, e over c squared. Done. Can't simplify any more than that. Number 6, solving for x. So we want x by itself. So first of all, I have an x on both sides. So I don't even know where I need to start clearing stuff out until I only have one x. So as is the rule when we're just solving it when there's all numbers, get rid of the smaller of the 2 x's. Clear it out. So this goes away. And now I have 6x plus 2y. So now I can isolate my x. I'm going to minus 2y on both sides. Well, that's going to clear it out on both sides. So I still have 6x. But over here I have nothing. This cleared out. So that's 0. Divide by 6, x equals 0. So for this one, I was able to simplify it all the way down to what x is equal to as a single number. Everything else canceled out. In number 7, we're going to solve this for t. This can be a little complicated here. I'm going to bring it down here so I can fully show what I need to do. This is division. A lot of people want to go ahead and multiply by x and call this, they would multiply by x on both sides and clear it and call this v times x, but that doesn't work. X is being divided by t and not vice versa. So if I want to get rid of this over here, divided by t, I can multiply by t. It doesn't work the other way around. So you can only multiply to get rid of the bottom here. So because remember, you're multiplying like this over 1. So if you actually multiplied across the fractions, you'd have x t on top and you'd have t on the bottom, and those cancel, leaving you just x, which is what we wanted. And then over here, you're going to have t times v. And you might say, we're done. No, we're not, because we're supposed to solve this for t. Okay, so if we're supposed to solve this for t, I don't have t by itself yet. So I'm going to divide by v now to get that away from the t. So I moved the t to the one side. Now I'm getting rid of the v. Final answer is x over v. So that's a little complicated right there. There's a property that you study later where you find out that when you have this situation, you can just switch these two, because look what we ended up with. T ended up here, and v ended up here. Now, we had to show all the algebra to get there, but that is a property that will always hold true. These steps will always work. So later on, when you're not having to show all of this work, you can just switch those. You are allowed to do that. All right, that's it for 4-7. Moving on to 4-8. So we're going to solve and graph these on a number line. Inequalities. Okay, so when they're set up like this, you can break them apart into two pieces. And you would basically cover this up and just write that. And then you would cover this up and then just write that. And you can solve them separately. Or you can solve them all at once, which is easier, which is what I'm going to do. But now you have dividing lines here and here. So you're actually going to have to do things 3 times, once on each side of those dividing lines. So a minus 5, I'm trying to get h by itself. I'm going to add 5. I've got to do it once over here, and I got to do it once over here. So negative 8 plus 5 is negative 3. Still have a 3h in the middle. And I have a 6. Now, if I divide by a negative, all of these flip, but I'm not dividing by a negative, so I don't have to worry about that here. This clears out, leaving me h. No flips. 6 divided by 3 is 2. Negative 3 divided by 3 is negative 1. H is greater than negative 1, so here's negative 1. Open circle. And less than or equal to 2. So here's 0 and here's 2. Closed circle. Less than or equal to 2 is going down. Greater than negative 1 is going up. When they're written like this, it's an and statement. Both have to be true at the same time, so I cannot pass these boundary points. It's everything in between. All right, this one is an or statement. Okay, so either one can be true to make this whole solution true. They're separate, so we're going to solve them separately here. So we're going to divide by 2. T is less than negative 3 over 2, which if you actually divide that is a nice decimal. So you can leave it as negative 3 over 2, but it's actually negative 1.5. Both are fine. Over here, add 6. Well, we don't want to do that yet. We got t on both sides. So we could minus this t. That's going to put a 0 over there. That's okay. That way we never have to flip because we're going to keep things positive. But I'm going to go ahead and minus 4t. Save myself a step. That's going to leave me negative 6 greater than or equal to negative 3t. That's a 1 minus 4. So I created a negative, and I'm just going to make sure I remember to flip. So divide by negative 3, flip it, and I get a positive 2. So we could have minus t first. That would have created a positive. Would have put a 0 there. Then you would have had to add 6 to the other side and then divide. We would have got the same answer. So t is greater than or equal to 2. So this is an or statement, either one of these. So let's think just about this one for a second. Less than negative 1.5, so negative 1.5. Less than goes like this. This one over here, greater than or equal to 2. 2's up here, greater than or equal to is going this way. So these two are never going to cross. 2 is up here, and it's going this way. Since it's an or statement, though, the answer doesn't have to fall into both of these. It can be either one. So this is actually what our graph is going to look like. Here's 0, negative 1.5, and 2. It's an or statement. There is no, if this was an and, there'd be no solution. There's no way for both of these to be true at the same time. But since it's an or statement, it can be less than 1.5 or greater than or equal to 2. All right, 13. This one is an and statement. Both have to be true. So let's solve this one first. Get y by itself. Plus 5, 6, divide by negative 6. Divided by a negative, so you got to flip. Don't forget to flip. Negative 1. Over here, minus the 50. So I get negative 50, negative 10y, divide by negative 10. Dividing by a negative, you have to flip it. Okay, and we get positive 5. This is an and statement. So it needs to be greater than negative 1, and it has to be less than 5. Closed towards the y is less than 5. You could rewrite this. Okay, when you see an and statement, you can always try and write it like this. So it's closed towards the y with the 5, so it would look like this. So this is fine, but this says the same thing. Notice, open towards the y when compared to the negative 1, closed towards the y when compared to the 5. So this is an interval, everything greater than negative 1 and everything less than 5. There are numbers that fit that both at the same time. Here's 0, negative 1, here's 5. Both open circles. So the numbers that are greater than negative 1 and at the same time less than 5 are everything in between here. Because it's an and statement, it's only those. Okay, 15, this is an or statement. Let's solve this one first. Plus 10, so 3s greater than 12 divided by 3. S is greater than 4. Add 15. 5s. This is gone. This is 10. Divide by 5. No flipping. All positives. Less than 2. It's an or statement. Think about this one. Here's 0. Here's 2. S is less than 2. This one. Here's 0. Here's 4. S is greater than 4. These will never overlap. 4 is up here. It's going this way. 2's down here and it's going this way. So if this was an and statement, it'd be no solution because none of these numbers overlap. But it's an or statement. Both are true. Both can be true separately because it's an or statement. So here's 0. Here's 2. Here's 4. So S is greater than 4. Looks like this. S is less than 2. Looks like this. Again, none of these numbers overlap. There is not a number that fits both of these solution sets, but since this is an or, all of these are possible answers, and all of these are possible answers. If it was an and statement, it would be no solution. All right, this one is an and. Let's solve it. X is greater than 2. We got to distribute here. And add 2. Divide by a negative, so we have to flip. Flip it. Negative 3. Now this is an and statement. Both have to be true. So x is less than negative 3. X is greater than 2. Here's 0, negative 3, 2. X is greater than 2. That's these numbers up here. How about this one? Here's 0. Here's negative 3. Here's 2. So x is less than or equal to negative 3. This is an and statement. So what number fits both of these solutions? Because that's what and means. And means it has to be greater than 2, and at the same time, it also has to be less than negative 3. There is no such number that's greater than 2 and is also less than negative 3. This is no solution. And if you were going to graph no solution, it is just an empty graph. All right, that is for 8. And last but not least, for 9, absolute value. So when we take the absolute value of a number, it becomes positive. If it was positive, it stays positive. So x minus 3, if it's giving us the answer of 16, that means inside here this expression is either producing 16 to give us this, or negative 16, and after you take the absolute value, it gives us this. So we have to account for both possibilities. X minus 3 could equal 16, x minus 3 could equal negative 16, and they both would make this true. So you got to solve for both. So just quickly solving these, x could be 19, or x could equal negative 13. Either one. So over here, 2 possible things. This expression inside here could be giving us positive 52, but it also could have gave us a negative 52, and this would still be true because the absolute value would make it positive. So what number goes in for A where this could give us negative 52? Solving them both separate. Minus 13. Divide. So A could equal negative 3. And that's negative 65. Divide by negative 13. And that's positive 5. So again, or statement, either one of these make this true. Same idea here. Okay, this could have been a positive 34 inside. This could have been a negative 34. So what value of x produces a positive 34? What value of x creates a negative 34? 2x equals 30, so x equals 15. Negative 38. So when I divide, it's negative 19. Now, inequalities can make this a little trickier, especially if you're trying to wrap your head around it, but there are some tricks. So even if you don't fully understand it, there's tricks to getting these right. So number 4, the value inside of this, when I plug something in for x, has to come out to something less than 2. So if I'm just thinking about positive numbers, I have to create a positive number that's less than 2. But if I'm coming up with negative numbers that make this still less than 2, after I take the absolute value, it can't be something like negative 10. Because if I get negative 10 inside of here, and then I take the absolute value, it becomes positive 10. And 10 is not less than 2. So it needs to create, after the absolute value, a positive number that is less than 2. For example, negative 1. If I get a negative 1 in here, and the absolute value then is positive 1, that makes this true. 1 is less than 2. So we're going to compare everything. The dividing line is going to be the opposite of this. It's going to be negative 2. But I actually need this value to come out to something greater than negative 2. I need x minus 10 to be greater than negative 2, because that's what negative 1 represents, or anything that's actually in the positives. Okay, so that's a lot to wrap your head around. So you can do those separately, and let's run those real quick. Plus 10, plus 10. So x is less than 12. That creates our positive answers that are less than 2. Add 10, add 10. X is greater than 8. So less than 12, greater than 8. We are graphing this solution. Here's 8. Here's 12. less than 12, greater than 8. That's everything between those two numbers. Now, if you can't wrap your head around that, here's the trick. You do x minus 10 is less than 2. You write it just like that. And whatever this is, you put it right here, and then you put the negative version right here. And this is it. This is what you're going to solve here, because this says the same thing as this. If you notice, it's open towards the x minus 10. It's open towards the x minus 10, closed towards the negative 2. Once you've got this, you could cover this up, and break it into two pieces. Or if you like solving this all at once, you could do that too, because here's going to be your 8. X is greater than 8, and here's going to be your 12. X is less than 12. So this works out. This is the fast way to do it. But I don't always like just teaching tricks, because then you don't necessarily understand why you're doing it. And if you don't understand why you're doing it, then you're just memorizing it for this instant, and it's not helping you down the road. So trying to make sure that we can wrap our heads around this as much as possible, but this is the trick. All right, so this one, if I'm going to use the trick, it's 5r plus 12 greater than negative 28, okay, or less than 28. So if we solve this all at once, let's see what happens. We are going to minus here, so that is 16. And this is negative 40, divide by 5. So negative 8. 16 divided by 5, that's 3.1. So r is greater than negative 8, and r is less than 3.1. That sounds like a great solution, right? Greater than negative 8, less than 3.1. So how come this is not true? So the problem is we need to look up here. This is a special case. Okay, so this is one of those situations where just running the trick isn't going to necessarily work for you. And again, this is why we go back to, you got to think a little bit higher than just, here's the trick, always do this. I'm just going to pick a random number, like up here, like 10. If I plug 10 in here, 5 times 10 is 50 plus 12, that's 62. And the absolute value of 62 is greater than negative 28. That's true. So why wasn't 10 included in this? Well, what about down here? Right? What about down here? If we have negative 10, 5 times negative 10, that's negative 50. Negative 50 plus 12. It's negative 38. But when I take the absolute value, it becomes positive 38, and it's greater than this. So when you got to look closely at this, forget what any of this says. The absolute value of anything is always going to be greater than a negative, because when I take the absolute value of a number, it's going to be positive. It could be 0 and it could be positive. So is it always greater than negative 28? The answer is yes. This is all real numbers. So it's a special case. We got to take a look at this and make sure it makes sense. Absolute value will always be greater than negative 28. Any number that I put in here, it's going to work. So whenever you see an absolute value being compared to a negative, you got to have a little bell go off and think, oh, this is a special case. And if it ever said less than a negative number, okay, don't start running things here. If it says less than a negative, that's not possible. The absolute value is not going to create something less than a negative number, because it's always going to create a positive. All right, so the last one. This has to create something that is greater than a positive. Okay, so that is possible. So this is one that we can use the trick for. So 4b plus 16. It could give us a positive number that is greater than 28, like 30. Then when you take the absolute value, it stays positive 30 and it's bigger. Or it needs to be less than negative 28, like negative 30. Because if I take the absolute value of negative 30, it becomes positive, and now it still fits the solution and it's greater. Okay, so the trick will work here. This was just a special case, because we're taking the absolute value, greater than a negative, that's always true. All right, so this one, let's go ahead and run these numbers. We're going to minus 16. Okay, so if I minus 10, that's negative 38. And then another 6, that's negative 44. And 28 minus 16 is 12. And I'm dividing by 4. Not dividing by a negative, so everything stays the same direction. This is 3, and this is negative 11. Okay, so b is less than negative 11, greater than 3. Less than negative 11, greater than 3. These create or statements. Okay, so when I start looking at this, I don't want to write it as an and statement like this. So when I solve it, I need to be aware that there's different, because if you looked at that and you said, well, this is an and statement. So what number is greater than 3 but also less than negative 1? You'd say, well, there is no such thing, right? And you say, oh, there's no solution. It's not possible. But I can just pick numbers right now that are going to work. If I plug in 100, 4 times 100 plus 16 is going to be greater than 28. So saying no solution doesn't make any sense. We need to split this into 2 pieces. So close towards the b. b is less than negative 11, or b is greater than or equal to 3. And that's another reason if we go back here, okay, and we look at this, this is an or statement here. R is less than 3.1, or R is greater than negative 8. If you think about it as an or statement, any number greater than negative 8, any number less than 12 is going to work right there. Okay, so now to put this on the graph, here is 0, here's negative 11, and here's positive 3. So less than negative 11 goes like this, and then greater than or equal to 3 goes like this.